Hello friends, welcome to my channel. In this video we discuss another important definite integral, and that has a specific name. We call it as a gamma function. Of gamma function is we define we define gamma function notation for is this capital gamma of n, where this n is greater than 0, as gamma of n equal to integration 0 to infinity e raised to minus t raised to n minus 1 into dt. This is a definition of gamma function. Now here we will see what happened to this integral if we put different values in this integral. Suppose first, if we replace this t as gamma of x, then you can see that limit will be unchanged, since at 0 we get 0, at infinity t equal to infinity we get x equal to infinity, but the small fraction dt will be changed, and it will becomes lambda into dx. Therefore gamma of n equal to integration 0 to infinity e raised to minus lambda x into lambda x whole raised to n minus 1 into lambda into dx. Lambda is a constant. We can take this lambda out of this integration. Lambda raised to n minus 1, and this lambda will be lambda raised to n into integration 0 to infinity e raised to minus lambda x into x raised to n minus 1 into dx. So this gives us the integration 0 to infinity e raised to minus lambda x into x raised to n minus 1 into dx equal to, transfer this lambda raised to n to left side, and this will become minus lambda raised to minus n gamma of n. Secondly, if we put t raised to n equal to x, again limit will remain unchanged in this case. As t equal to 0 we get x equal to 0, and t tends to infinity we have x tends to infinity. But from this the t will be x raised to 1 by n, and dt will be 1 divided by n into x raised to 1 divided by n minus 1 into dx. Let us put this value. Therefore gamma of n equal to integration 0 to infinity e raised to minus t minus x raised to 1 by n into t raised to n minus 1, that is t x raised to 1 by n whole raised to n minus 1 into dt, 1 by n into x raised to 1 minus n divided by n into dx equal to 1 divided by n constant integration 0 to infinity x raised to e raised to minus x raised to 1 by n, and here you can see that x raised to n minus 1 and 1 minus n will be cancelled, and we have x raised to 0. X raised to 0 is 1, so we have simply x. Transfer this n to this side and we get the integral value, integration 0 to infinity e raised to minus x raised to 1 by n into dx equal to n into gamma of n. So this is the another direct result which we can obtain from the definition of gamma function. Now let us, if we transfer this e raised to t terms directly, what happens to the definition? Or let us see the third result. If we put e raised to minus t equal to 1 divided by x, e raised to minus t equal to x, we are substituting e raised to minus t equal to x, then e raised to minus t equal to x, then e raised to t equal to 1 divided by x. 1 divided by x, taking log, we have t equal to log of 1 divided by x, and log of 1 minus log of x. Log of 1 is 0, that is log of minus log of x. Then dt equal to minus 1 divided by x into dx. This is the value of dt. In this case, now the limit will be changed. What happen if we put t equal to 0? T equal to 0 we have when t equal to 0. T equal to 0, e raised to 0 means 1. So x, we have x equal to 1. When t tends to infinity, this is 1 by t, 1 divided by e raised to t. As t tends to infinity, this tends to bigger value, and 1 divided by infinity means it will be tends to 0, and hence x tends to 0. So that this term gamma of n equal to, it will convert into, limit will be changes, t equal to 0 will get 1, x equal to, and t tends to infinity will gives us a 0. E raised to minus t equal to, now let us, it remains to calculate dt. Okay, so e raised to minus t into dt equal to minus dx. Here t raised to n minus 1, means t equal to, we have here log of minus x minus log of x raised to n minus 1, and e raised to minus t into dt equal to minus dx. Okay, equal to, we write this as minus integration 1 to 0 minus log of x raised to n minus 1 into dx. Now changing the limit, when we change the limit, then upper limit, lower limit, upper limit, then sign will be changed, and this will be integration 0 to 1. We write this as minus 1 raised to n minus 1 into log of x whole raised to n minus 1 into dx equal to minus 1 raised to n minus 1 integration 0 to 1. This is same as log of and minus again, here we have minus log of x whole raised to n minus 1 into dx, but this is a log of, minus log of x is what? Minus log of x is log of 1 by x, and hence this is equal to integration 0 to 1 log of 1 by x into dx. So this is what we have, gamma of n equal to integration 0 to 1 log of 1 by x into dx. This is another deduction which we get directly from the definition of gamma function. Now friend, we apply the definition of gamma function to calculate one of the more important result, or gamma values. What is the gamma value? Gamma of n equal to integration 0 to 1 e raised to minus t into t raised to n minus 1 into dt. Now if we evaluate this, this is my first function, this is my second function by integrating parts, then what we get? T first function t raised to n minus 1 into integration of second e raised to minus t divided by minus 1 between the limit 0 to infinity, minus integration 0 to infinity, derivative of the first function n minus 1 t raised to n minus 2 into integration of the second e raised to minus t divided by minus 1 into dt. Okay, now What is the value of this? E raised to minus t tends to e raised to minus t. That means 1 divided by e raised to t. T tends to infinity. 1 by e raised to t tends to infinity, and therefore this value tends to 0 as t tends to infinity, and hence at first at upper limit it will be 0, and again at lower limit t, due to this t raised to n term we have 0. Okay, at upper limit we have 0, at lower limit we have 0, and hence we get 0, and this will be minus minus plus n minus 1 into integration 0 to infinity e raised to minus t raised to n minus 2 into dt. But what is this? This is equal to n minus 1 into gamma of n minus 1. This is our gamma of n. Now if we put n by n plus 1, then gamma of n plus 1 equal to n into gamma of n. This is important result we get about the value of gamma, right? Now if we continue this, then n into gamma of n is n minus 1 into gamma of n minus 1. Again n into n minus 1 into gamma of n minus 1, applying the same criteria, n minus 2 into gamma of n minus 2. So if we continue this process, then we arrive at n into n minus 1, n minus 2 up to 3 into 2 into 1 and gamma of 1. Now let us calculate the value of gamma of 1. What is if n is equal to 1? Value of gamma of 1, this will gives us integration 0 to infinity e raised to minus t into t raised to 1 minus 1, t raised to 1 minus 1, t raised to 0, and t raised to 0 is 1. Integration of e raised to minus t divided by minus 1 between the limit 0 to infinity equal to minus 1 divided by e raised to t between the limit 0 to infinity, minus 1 into, at upper limit it is 0, at lower limit e raised to 0, e raised to 0 is 1, so it is a minus 1. This minus and this minus will be plus. So gamma of 1 equal to 1, then substitute here gamma of 1 equal to 1, then we get, and another important value of this gamma function is gamma of n equal to gamma of n plus 1 equal to, we have n into n minus 1 into n minus 2 up to 3 into 2 into 1, and we know that this is an n factorial. So gamma of n plus 1 equal to n factorial. This is an important result what we have now about the gamma function. We have two important result about the gamma function. First one is gamma of n plus 1 equal to n into gamma of n. Second one is gamma of n plus 1 equal to n factorial. So this result will be very useful while we evaluate the more complicated integral, definite integral, and in that case we need this integral, and therefore it has its own applications in higher mathematics.